video, we're going to factor another kind of polynomial, but just like factoring out the GCF by undistributing in the last video, in order to figure out how to factor, we often need to look at the multiplication that comes first. So let's think about what happens when you FOIL, which remember is just a silly word for multiply, two linear binomials. Let's think about what those words mean. Binomial means the sum of two terms. And linear means both terms will have just an x. That means x to the first degree, not x squared or anything bigger than that. That's what it means to multiply two linear binomials, like x plus 3 times x plus 4. So of course, if we FOIL these out, we all know we can do this. X times x, x times 4, 3 times x, and 3 times 4. And what's going to be key here is as long as we are starting with linear binomials and nothing different between the two factors, what's going to happen with these middle terms is they're always going to be like terms, and we're always going to be able to combine them. And so we'll end up with a trinomial, which means a polynomial with 3 terms. And I just want to make sure we notice the pattern here. That final constant, talking about that 12 at the end, that's the constant because there's no letter next to it. What does that have to do with the 3 and the 4? Well, it is the product of 3 and 4. Notice how we started with a 3 and a 4, and we ended with a 12, which is the product of 3 times 4. And then we can turn our attention to the middle term. We should really have asked, what is the coefficient of the middle term, this 7? What does that have to do with the 3 and the 4? Well, 7 is the sum of 3 plus 4. Right? 3 plus 4 equals 7. And that is always, 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 always going to be the case. In order to factor a trinomial, we need to look for two numbers that are the product of the last constant, and whose product is the last constant, and whose sum, when you combine them, is the middle coefficient. So we'll look at a couple of examples that would make sense. All right, look at a couple of examples so that this makes sense. X squared plus 9x plus 20. We need to find two numbers whose product is 20 and whose sum is 9. It is certainly possible that you get it just by looking. That's fantastic. If you don't get it in the first 8 seconds of looking at it, stop staring, stop looking, make a list of numbers that multiply to 20. That's where you want to focus because that's usually not going to be such a big list. So make a list of numbers that multiply to 20. 1 times 20, 2 times 10, 3 does not go into 20, 4 times 5. And if you're orderly about it, if you go kind of down this list here in order, you'll see that you don't have to you don't have to keep going through all the big numbers because you'll have covered them already. When the 5, 10, and 20, the bigger numbers that go into 20, we've got them already. So that's why we go in order. And then we just, as soon as you notice the pair that works, we're looking for a pair that add up to 9. Well, we've got 4 and 5, so our factors are x plus 5 times x plus 4, and that's it. Looking at the next one, x squared plus 14x minus 72, I want you to notice here that minus sign makes a big difference. Because we're looking for two numbers that multiply or have a product of negative 72, that means that one of them has to be positive, the other one has to be negative. And we're looking for two numbers that have a sum of positive 14. Well, if one of them is negative and the other one's positive, I really shouldn't use the word sum, because when you combine a positive number and a negative number, when you add them together, you actually end up canceling some of it out. So I'm really going to say combine to 14. And again, since the product is negative 72, one of our two numbers must be negative. But since they combine to a positive 14x, when you combine two numbers, one's positive, one's negative, the end result, of course, is going to be the sign of the bigger, stronger number. Well, if they combine to make positive 14, that means the bigger number must be positive. So we need two numbers that combine to make 14 when you kind of subtract them from each other to cancel out. The bigger one's going to be positive, the smaller one's going to be negative. If you look and you don't see it right away, that is fine. Give yourself 8 seconds or so, and if you don't see it, just start making the list. I promise it saves time in the long run if you make the list sooner rather than later. So numbers that multiply to 72. 1 times 72. 2 times 36. 3 does go into 72. 3 times 24. 4 goes into 72. By the way, a cool trick here, if you're not sure how many times 4 goes into 72, you can think, well, 2 times 36 works. Well, if I take 2 and I double it, that must mean that I took the 36 and I cut it in half. Sorry, I forgot to double when I said double. Take the 2 and double it to make 4, balance that out by taking the 36 and cutting it in half. And so 4 and 18, I could keep going. There are more numbers that multiply to 72, like 6 and 12, and 8 and 9. But I already found the pair that works. 4 and 18, because the bigger one is positive, but the smaller one is negative, those do combine to positive 14. X plus 18, x minus 4. That would be your answer.